In this video, we're going to be teaching you how to use a feature on your calculator, which is nDerive, which will find a derivative at a specific point. So I'm going to go through the steps that are also shown on your sheet. As you watch this video, you should have your graphing calculator out, and you should also have your nDerive worksheet in front of you so you can follow along. Feel free to pause at any time if you need to write things down. So in this first one, we're going to get this first screen where we get nDerive. So if you hit your math menu, and it's the 8th one, so you can't see it, but if you just hit the number 8, it pops up. And the function we're going to be working with here is sine of tangent of x. And we want to know the derivative with respect to x at 2. And when we press enter there we go, we've got our answer. So this is the derivative of sine of tangent x at 2. Now I do want to take a moment to show you, if you have the TI-84 Plus and the new operating system, you're going to have a much nicer look. So and a second, let me tell you what I was doing here. If you hit mode, and you're going to see this next down here, that tells you that you've got this new operating system. And if you scroll down there, right here, where it's blinking, it says Math Print. I'm on Classic, and I'm going to press Enter on Math Print. And now, if I hit second quit, and now if I do Math and choose 8, it looks completely different, but this is going to make total sense because this is saying take the derivative with respect to x. So I throw an x in there using my x key. I go over here and put my function. So it was sine of tangent of x, and I want the derivative, and notice I'm just arrowing to get to the other box when x equals 2. So here we're doing the exact same thing. d dx of sine of tangent of x when x equals 2. I press enter, and there's the same answer, negative 3.328. All right, so I'm going to do this a couple different ways, and I'll do number 1 with you. So here's number 1, and we've got this lovely function here, x to the 5th plus the cube root of x to the 4th minus natural log of x. So here we go. For this one, I'm going to stay in this mode, and then I'll do it with the other one. So math 8, and I'm going to do x, and then I'm going to go over here, and I put in my function. So I have x to the 5th, and then plus, and it really still helps to be smart about this, x to the, this is going to be the 4/3 power. So I'm not going to actually write cube root of 4 to the 4th. I'm just going to make it to the 4/3 power. This, by the way, is the nice thing about this math print, because it also puts the exponent in the exponent, minus natural log, natural log of x. Close that parenthesis, and I want this all when x is 2. I press enter, and there's my answer, 81.180. Now on the AP exam, anytime you use your calculator, you can round to 3 places, but you must round to 3 places at least in order to get credit. So we're going to write that answer down right here. We have 81.180. Okay, I'm going to bring this back up, and I know most of you probably do not have it looking like this, so we're going to go back to the other form. So I'm going to hit mode. I'm going to go back to classic, and let's go up here. We're going to choose classic, press enter, hit second quit. And now if I do second entry, the one I just had, it looks the way it would if you did it. So nDerive, x to the 5th plus x raised to the 4/3 minus natural log x, x comma, and this time I want to do it at pi. So I have second pi, and press enter, and there's my next answer, 488.680. So let's put that one in there, 488.680. I also want to point out, if you're rounding to 3 places and the third one is a 0, you still have to write that 0 to show that you were going to 3 places. Now I want to show you one more way to do this, which is to actually put that equation into y equals, because it's a pretty messy equation. So I can do x to the 5th, and then I've got plus x to the, I need parentheses here because I'm in this format, to the 4/3 minus natural log x, And now, when I do it here, I'm going to clear this. I'm going to hit Math 8. And now, watch vars, yvars, function, y1. So I don't have to type the whole thing in there. y1, comma, x, comma, and this time I want e, so e is sitting over here. And there it is. My next answer, 274.484. So let's write that one in. So 274.484. All right, so just to review that step, I'll go do the previous one like that. So if I do math 8, and I go vars, yvars, function, y1, because that's where I have my equation, comma, x, comma, we'll do the previous one, which was with pi. There we go. And you'll see, there it is. All right, so the rest of them, 2 through 3, are just the same idea, more practice. Make sure you use parentheses in a fraction like this. And hopefully you have the latest version of this worksheet, which has this as having absolute value. So those should be absolute value. If not, fix that on your worksheet. All right, together with you, I'm going to do number 5 next. And so in this one, we're given this very ugly function, the natural log of the tangent of the sine of e to the x. And we're asked to find the tangent line, and we're supposed to use our calculator to help us with this. So I'm going to show you how this works out. So let's start off by going into our y equals and putting that function in here. So we've got the natural log of the sine, nope, wrong, natural log of the tangent of the sine of e, where is it, e to the x, e to the x, and then I gotta close a few parentheses, 1, 2, 3, I think that's enough. Okay, so we've got that in our y1, and now I'm going to hit second quit. And the first thing I want to do is get this at x equals 0. So you'll notice that in this problem, I was interested in all of this when x equals 0. And the first thing I want is my y value. And I can go to this vars, yvars, function, y1. And if I do parentheses 0, that'll give me the value at 0. And there it is. So I know that oops, I don't want to be in highlighter. Let's get to a pen. So I know that y at 0 equals, and what was that number? Oops, wrong thing. That number is 0.112, rounding to 3 places again. And then the next thing I need is my derivative, so y prime at 0. So we'll go back over here. No, not there. My calculator. There we go. And so now I go math 8 vars, yvars, y1 there, and comma x, comma 0, because I want my derivative at 0. Press enter, and there it is, 1.087. 1.087, and now I have my point, and I have my slope, and so I can write my equation. Y minus 0.112 equals 1.087 x minus 0, and I've done the problem. All right, this next problem is going to ask us to consider what happens with our function 1 over x and 1 over x squared. So let's start with a clear screen. Those are really easy functions, so I'm going to just put them right into nDerive. So I'm going to do 1 divided by x, which is my function, comma, x, comma, and I'm looking for the derivative at 0. I'm going to press enter, and oh, that's a big number. It looks like it's about 1,000,000. So let's just put that down, 1,000,000. Double check that that's how many zeros. Yeah, 1, 2, 3. Yep, 6 zeros. And then the next one asks me to do the same thing for 1 over x squared. Hopefully you know that if I hit second entry, I can actually go in here and edit this. And I'm going to do second insert, and I'm going to square that. Press enter, and this one says the derivative here is 0. And it asks you what you think of those answers. You should be bothered by these. You should realize that these functions have vertical asymptotes. So let's start with 1 over x. So 1 over x looks like this and like this. And we can see that it is not continuous at 0. Therefore, it does not have a derivative there. So how did it get this number 1 million? Well, what the calculator does is it takes this point here and this, oh, you know what? I drew my graph wrong. Let's fix that up. Sorry about that. So let's see. Our graph looks like this and this for 1 over x. And it takes a point down here and a point up here, and it finds the slope of that line, which is really quite steep, and that's why it got 1 million. So in a similar vein, on this one, the graph looks like this and like this, and it picked the last point it plotted here and the next point it plotted here, and look at that, the slope is 0. And so that's how it got those problems. So the moral of the story is, what should you watch out before using nDerive? You should make sure that the function is continuous. So make sure the function is continuous at the x value. Okay, so you need to be smarter than the calculators, basically what we're telling you. All right, the next problem we want to look at here is I'm talking about how you could actually graph the derivative on your calculator. So I'm going to take one graph we know well, and we're going to start off with a really simple graph of, I don't know, let's go with sine x. So we're going to graph sine x, and let's go with a trig, a window. So let's go with window number 7. There it is, sine x. And what we're going to do in our y equals is we're going to graph the other one as using nDerive. So we're going to do math 8, and we're going to do the derivative of y1. So here we go, vars, y vars, y1, and we're going to do comma x like we did before, comma, and here we're going to put in x because we're going to do it at every value of x. And we're going to press enter, and when we graph it, oops, got to hit graph. When we graph it, there we go. And as we watch this, we should realize, hey, that looks like the graph of cosine, which makes total sense because cosine is the derivative of sine. So I've done one of them for you. I tested it with y equals sine x. Now you're going to do another one. So you pick another function where you know what the derivative would be and make sure it works for you. All right, the last problem we're going to do together here is number 8, which asks us to find how many critical points. It doesn't ask us to actually find them, just how many critical points. I'm going to show you a nice, easy way to do this. So we're going to go into here, y equals, and I'm going to clear out this first function, and I'm going to type in what it says. So sine of 2x parentheses and cosine of x to the 4th. And if I start hitting graph on this thing, I'm like, whoa, wait a second, that looks crazy. And then I'm like, wait a second, I only want the interval from 1 to 2. You can stop something graphing by pressing on, and then we can go to window, and I only want to see this thing from 1 to 2. So let's do that, from 1 to 2. And now I'm going to hit graph, and I want to know how many critical points it has. And so, right now it's a little hard to see. Oh, sorry. Let's just step back a second. I am graphing two things. The first one is the function. The second one is the derivative. I only want to see the derivative. So I'm going to arrow back, and I'm going to press enter on this equal sign. If an equal sign is not highlighted, it won't graph it. I only want to graph the derivative. So here we go. Here's my derivative. Now it takes a little while because it is actually doing nDerive for every one of these points and basically playing connect the dots. And so if you have a complex function, it takes the calculator a little time to figure it out. All right, so here we go. And I'm going to bring that graph over here. And what we have here is, and so let's just label what we have here. This is number 8, and this is the derivative. So the derivative for y prime. And it starts here at 1, it ends here at 2, and I want to find out how many critical points. Well, the critical points are when y prime equals 0. So let's just count how many of those we have. We have 1, 2, 3, 4, 5, 6 of them. So our answer, number 8, would be 6. I'm going to let you do number 9 on your own.